Hello students. In previous session we have learned tissue systems in plants. There are three types of tissue systems. Epidermal tissue system, it is usually parenchymatous. Ground tissue system, which includes mechanical layer hypodermis, storage region cortex, then single layered endodermis, and then comes pericycle. And the vascular tissue system, which consists of vascular bundles. In today's session, I will be explaining anatomy of root both in monocot and dicot. When you take transverse section of root, now root is descending axis of the plant, usually develops from the radicle. It may be taproot, fibrous root or adventitious root. Any root shows 5 regions: root cap region, meristematic region, elongation region, maturation region and conduction region. A TS passing through well-developed root shows following layers. The outermost layer, it is represented by single layer of barrel-shaped, thin-walled parenchyma cells known as epiblema. Here, this layer is not covered by cuticle. The parenchyma cells of epiblema produce unicellular root hairs which helps in absorption of soil water. Hence, epiblema is also known as piliferous layer. Then, the second layer inside epiblema is cortex. Cortex is big in monocot root and it is small in dicot root. This cortex is composed of loosely arranged oval-shaped parenchyma cells showing lots of intracellular spaces. The third layer next to cortex is endodermis. This endodermis is again having barrel-shaped parenchymatous cells which are compactly arranged. Here, some cells are thick-walled due to deposition of suberin. So, suberized cells we call Casparian band cells and non-suberized thin-walled cells are called passage cells. These passage cells will form the channels to carry the water from cortex to pericycle and then directly the water enters in the xylem elements. Next to endodermis, it is the pericycle. It is also single layer of compactly arranged thin-walled parenchyma cells. It is outermost layer of the stele. Stele is representing the central axis. Inside the pericycle, xylem and phloem are arranged on different radii. So this kind of arrangement we call radial vascular bundles. In between xylem and phloem, there are medullary rays also known as conjunctive tissues. These are extension of pith or the central portion is called as medulla. Pith and medulla is composed of parenchyma cells. So here when you look at the layers in the root, epiblema with root hairs, cortex multi-layered, endodermis with Casparian band cells and the passage cells. Then comes pericycle, again parenchymatous, and then pith or medulla extended as conjunctive tissue or medullary rays. All these layers are made up of parenchymatous tissue. It is adapted according to the arrangement within the root. Xylem is always exarch. As protoxylem is towards pericycle, metaxylem is towards pith. This is about anatomy of dicot and monocot root. In dicot, the pith is reduced. In monocot, pith is well developed. In dicot, the number of vascular bundles are 4, hence called tetrarch. In some dicot plant, there are 6, hence called hexarch. While in monocot root, there are many vascular bundles, hence the condition is said to be polyarch. When we compare dicot root and monocot root, in both the roots, epiblema with root hairs is common. Cortex multi-layered region is common, but if you see the size, cortex in dicot root is big and cortex in monocot root is small. Endodermis is again common with passage cells and Casparian band cells. Pericycle is also same, but the stele portion is bigger in monocot root and smaller in dicot root. Number of vascular bundles are many, so polyarch condition in monocot root, tetrarch or hexarch condition in dicot root. Reduced pith or medulla we can see in dicot root, and well developed big functional medulla or pith we can see in monocot root. With this, I'll conclude this session on anatomy of roots. Thank you.